In this lesson, we're going to be talking about polygons. So a polygon is basically any shape that has sides. A regular polygon is a shape where all the sides and all the angles are equal. So this shape here is not a regular polygon because the angles inside of it are different. At first glance, it looks like the sides might all be the same length, but if you look at the angles in here, you've got acute angles here, whereas you have some obtuse angles here. So this angle looks like it's less than 90, and this looks like it's greater than 90. So this is not regular because the angles are not equal. This is not a regular polygon because, again, the angles are not equal, but also the sides are not equal. And this last one here is regular because you can see the sides are all the same, and if you look at any angle in here, they all appear to be the same. So this would be a regular polygon. We have some names for polygons. We, in the previous lesson, just talked about triangles and quadrilaterals. These names are all based on however many sides a polygon has. So a pentagon has 5, hexagon has 6 sides, heptagon, octagon, nonagon, decagon, dodecagon. Those are our most common polygon names. Now, inside of a polygon, we have certain features. We obviously have the side, which I think is pretty obvious. It's the side of the shape. But we also have things called interior or internal angles. Those are formed between the sides. So this here would be an internal angle. We also have diagonals. Diagonals are basically a line drawn between one vertex or corner in our polygon to another. And we can draw between any vertex or corner to any other corner, and we form these diagonals. Central angles are made up by where those diagonals meet the center of the shape and form an angle between other diagonals. So we can have these angles that form in the middle of our polygon. Now, if we look more at internal angles, you've already learned that the angles inside of a triangle add up to 180. You learned that a few years ago. You may also know the angles in a quadrilateral will add up to 360 degrees. So if you add up, for example, in a rectangle, we have 4 angles that are all 90 degrees. Those will be a total of 360 degrees. Now, when we want to find the sum of the internal angles of any other polygon with however many sides, we can use this formula. 180 degrees times n minus 2, where n is the number of sides. That will tell us the total of all of the angles inside of a polygon. Now, to find the measure of just one of those angles, if it's a regular polygon, meaning if all the angles are equal, we can just take that number, 180 times n minus 2, and divide it by the number of sides, which is also the number of angles. That will tell us the measure of one of those interior angles. Now, when it comes to central angles, the sum of these central angles, so these angles around the center of a polygon, is always equal to 360. If you wanted to find the measure of one central angle, you would take 360 and divide it by n, the number of sides in the polygon. And if we're looking at diagonals, a diagonal runs from one corner in a polygon to another, as we mentioned, and the number of diagonals, so the number of lines you can draw through your shape, can be used using n times n minus 3 divided by 2, where n is the number of sides. So if we were working with a regular heptagon, you can go back over here and you can see that a heptagon has 7 sides. So this has 7 sides, and it's regular. So that means all the angles and sides are equal. So the sum of the interior angles will be 180 times 7 minus 2, which is 900 degrees. So if I take all of the corner angles and add them up, it will be 900 degrees. Now because it's regular, I can find the measure of each angle. So you can use this formula up here, 180 times n minus 2 divided by n. I already did the top part of that formula. It's right here. So 180 times 7 minus 2 over n. I know the top of this is 900, and we just divide that by 7. It means each angle measures 128, we'll round it to 129 degrees. The sum of the central angles, it doesn't matter how many sides a polygon has, the sum of the central angles will always be 360 degrees. The measure of each central angle will be 360 divided by the number of sides, so 360 divided by 7. In this case, I'll just round it to the whole, so it's 51.4, so I'll just round it to 51. And the number of diagonals is n, so 7 times n minus 3, 7 minus 3, divided by 2, which is 14 diagonals. So those are your features of polygons.